Hey guys, Mr. Bowman here. Our learning objective is in blue. We're learning to extend our integration skills. So I'm going to underline that word integration. Just a recap from yesterday, that is also called anti-differentiation. And that's essentially the opposite of differentiation. So we're increasing the powers time. And hopefully you do recall we had our formula that was on the right hand side and we've applied that to a few examples. So what we're going to do is we're not going to dwell too much on the concepts. We're going to get straight into some questions that allow us to extend what we already know with our integration skills. So the first question will be a bit of a recap. So 8x cubed plus 5x to the power of 4 plus 1 dx. So first step is the circled bit in yellow just above it's k divided by n plus 1, so that's going to be 8 divided by 3 plus 1. So that power, we're then going to add 1. We're then going to go x 3 plus 1, and that is the first component. We're then going to deal with the second component. We're going to go 5 divided by 4 plus 1. So 5 being k, 4 plus 1 being the powers, and then that's going to be times x 4 plus 1, and from there we're just going to add 1x, and we can actually ignore the 1. We'll just write x, and then after that we're going to go plus c. We're then going to simplify our line of working. We're going to 8 divided by 4, that's going to get us to 2x to the power of 4, plus we've got 5 divided by 5, that comes to 1, so we can ignore that. That'll be x to the power of 5 plus x plus c. And that there would be our integral of our original equation. If you were wondering where we got 1 all the way to x from, just a reminder that that 1 is actually x to the power of 0. And if you integrated that, that would have been 1 divided by 0 plus 1 to the power of or x to the power of 0 plus 1. And then that becomes 1 divided by 1, x to the power of 1. All of those 1s go away, leaving us with an x. So that was our first question, bit of a recap from what we did yesterday. Let's change pen colors into green. Question 2, so we're now going to look, well, what if constants apply? Or we've got other variables in play. So ax cubed plus bx squared plus e. And let's say we're trying to differentiate or integrate that with respect to x. We're going to follow the same process. K, in our case, will be the a, the b, and the e. So that's going to be a divided by 3 plus 1, x to the power of 3 plus 1, and then we're going to add b divided by 2 plus 1, and then we're going to go x 2 plus 1, and then we're going to add, so just a reminder, that is ex to the power of 0. So it's going to be e divided by 0 plus 1 times x to the power of 0 plus 1, and we're going to add our constant at the end. And when we simplify this, this is going to be a divided by 4, x to the power of 4, plus b divided by 3, x squared, plus ex plus c. And that would be our integral for the second question. So that was with respect to having another variable or other pronumerals within our equation. So let's change to the orange one. Let's see how we go. So equation number 3. So let's put that up there. So 3, we are now going to integrate, well, what if the power's on the bottom? So 2 divided by x squared dx. So the first step would actually be to simplify our equation. So that would be 2x to the power of negative 2 dx. So what we've done is we moved the 2 up to the top, and that allows us to integrate a bit easier. We can then go through our process. So that's going to be 2 divided by negative 2 plus 1 times x, negative 2 plus 1, and we're going to add c to the end. this is going to end up being 2 divided by negative 1, which is negative 2, times x to the power of negative 1 plus c. Since we have a negative power, we're now just going to drop that down to the bottom. So that's going to become negative 2 divided by x to the power of 1, and we can ignore that 1. And we are then going to add c. And that's just an application of how to integrate with negative powers. So what I'm going to do is I'm going to pause the video. I'm going to clear some of our working. If you haven't got these examples down and you do not understand them, don't move ahead until you understand them. Get them down, and then we'll get into the next two questions. Okay, guys, we're back for our last two questions. Question 4, we're introducing, well, what happens if there's square roots or fractional powers? And question 5, it's just got a bit of each. It's got a power on the bottom with a square root on the bottom as well. So let's get into the first one. So before we can move ahead with this, so what's the integral of the square root of x to the power of 5? We must change it to a form that is easier to integrate. So let's change that, and we're going to convert the x to a fraction. And if we did that, that's going to be x to the power of 5 over 2 dx. Once we've done that, that looks a bit easier. We're more inclined or happier to integrate this. So our k value is going to be 1, and we're going to go 5 over 2 plus 1. So power plus 1 times x, 5 plus 2 to the power of 1. Sorry, 5 divided by 2 plus 1. Then we're going to add c to that. And once we've done that, we're just going to do our maths. So that there becomes 7 over 2, x 7 over 2 plus c. The 2 is then going to move up to the top. So that's going to be 2 over 7, x 7 over 2 plus c. And the last step, I'm just going to make this fractional power back into square root form. So that's going to be 2 times the square root of x to the power of 7 divided by 7 plus c. So hopefully that made sense. These are getting really tricky. We are ramping up in difficulty as well. So well done if you did get that. Just a reminder, please pause the video. Make sure you get the example down step by step. Make sure you understand what's happening. And question 5, our last one. So we've got 1 divided by x cubed plus 2 divided by the cube root of x. And we're looking to integrate that. First step, we do need to convert this into a form where the integration will be easier. So let's try to make the power on the bottom a negative power to the top. And let's try to convert square root or cube root into a fraction. So that's going to be x to the power of negative 3 plus 2 divided by x to the power of 1/3 dx. We've still got an issue. We've got an x on the bottom, which we're not big fans of. So we're going to change that again. So that's going to be the integral of x to the power of negative 3 plus 2x to the power of negative 1/3 dx. So I've now got them both in polynomial form. They're not at the bottom. They're not in their square roots. We can now go through and integrate. So x negative 3, well, that's going to be 1 divided by negative 3 plus 1 times x negative 3 plus 1. And then we're going to add that. So it's going to be 2 divided by negative 1/3 plus 1 times x to the power of negative 1/3 plus 1. And then that's going to be, we don't need the dx there actually. That's going to be plus c. We then look to simplify. So this part here, negative 3 plus 1 becomes negative 2. So that's actually going to be negative 1/2 times x to the power of negative 2. We're then going to add, well, what does all this stuff come to here? That's going to become 2 divided by negative 1/3 plus 3/3, which should become 2/3. So I'm going to get rid of all of that, and I'm going to write 2/3 x to the power of 2/3, and we're going to add c for that. In case you're wondering, that mathematically is the same as the new power. We can then look to simplify. So we've got a negative power here, and we've still got a bit of simplifying to go. So that negative power means it's going to go to the bottom. So it's negative 1 divided by 2x squared. And we're then going to add that 3 moves up to the top. So it's going to be 6 divided by 2. And we're going to convert that, and that's going to be multiplied. So we'll convert this fractional power into a square root. So that's going to be the cube root of x squared plus c. We then look to our final step of simplifying. That's 6 divided by 2. That's just 3. So that makes our life a bit easier. So it's going to be negative 1 divided by 2x squared plus 3 times the cube root of x squared. And we're going to add in our unknown constant as well. So that's our last question in today's video. That was the hardest one we're going to do. But just to recap, we did a couple questions. What happens if there are other variables? What happens if there's square roots? What happens if there are negative powers? We do need to be aware of how to deal and integrate with every single one of those scenarios. So hopefully you found the video useful. Now let's get into heaps and heaps of practice.